So we're going to put our 3p squared here and my negative 5 down there. And then we're looking for numbers that multiply to make negative 15 and add to negative 2. So if you got to multiply to negative 15 and add to negative 2, I'm thinking maybe a negative 5 and a 3. Negative 5 times 3 is negative 15, negative 5 plus 3 is negative 2. And then I'm going to put those numbers into my box so that this box represents this. So if I add all these pieces together, I get that. And it doesn't matter where I put the 5 and the 3. Either way, you can try it. It'll work no matter what. Then I'm going to just look at the top part of the box, and I'm going to factor out a greatest common factor. We're good at that. So I can take a p out of both of those. And if I do, I'm left with 3p minus 5. And then I'm going to do the same thing for the bottom. So ignore the top, pull out a greatest common factor from here. Well, the only thing I can pull out is a 1. And hopefully if I do that, I'll be left with 3p minus 5. Yay! I picked the right numbers, everything worked out. And so then my factoring is just what's left. I've got the 3p minus 5 times the p plus 1, and I'm done. And you could check it by foiling, but this is your foiling, right? That's 3p times 3p squared. Everything's working out. It's kind of a nice area model. So I'm just going to do a bunch quickly, and maybe I'll do another video later with more of why this box is so magical. But yeah, let's just keep going. So if I look at number 2 here, I'm going to draw a box. Going to put the 2n squared up there, going to put the negative 9 down there. Going to find things that multiply to make negative 18 and add to 3. So multiply to make negative 18, add to 3, I'm thinking a negative 6 and a 3. Negative 6 times 3 is negative 18, negative 6 plus 3 is 3. So I'm going to put those numbers in here, negative 6n and 3n, to make my middle 3n. So negative 6n plus 3n is 3n like I planned. That represents everything there. Then I'm going to focus my attention on the top of the box, take out a GCF. So I'm going to take out a 2n, and I'll be left with n minus 3. And then I'm going to focus my attention on the bottom. I'm going to factor out a 3, and hopefully I'll be left with n minus 3. Yay, it's working. And so my factors are down here. I have a 2n and a positive 3, so 2n plus 3 times n minus 3. Doesn't matter what order I write these, nice and commutative, however you like it. We're going to do it again. So look at this guy, draw a box, 3n squared up here, negative 4 down there. I need numbers that multiply to make 12 and add to negative 8. So multiply to make 12, add to negative 8, I'm thinking a negative 6 and a negative 2. Negative 6 times negative 2 is positive 12, negative 6 plus negative 2 is negative 8. So I'm going to put those in here, negative 6n, negative 2n. And again, focus my attention on the top, pull out a GCF from those. I can pull out a 3n. I'll be left with n minus 2. And you can check, 3n times n is 3n squared, 3n times negative 2 is negative 6n. Do the same thing for the bottom, focus your attention on the bottom, pull out a negative 2 from there. Hopefully I'll be left with, oh, that was a plus 4. There we go. Now it works. Negative 2 times negative 2 is a positive 4. Wonderful. So 3n minus 2 times n minus 2. That's how that factors. We do it again. So I look at this guy. I pull out a 5, put the 5n squared there, put the 12 down there. I'm looking for things that multiply to make 60 and add to 19. Let's see. How about a 15 and a 4? 15 times 4 is 60, 15 plus 4 is 19. So I'll put a 15n and a 4n there. Now you're like, oh my gosh, I don't think I would see that right away. So what do you do if you're trying to look for things that multiply to make 60 and add to 19 and you don't see them? You go off to the side and you start with 1. You're like, well, 1 and 60 add to 19? No. Will 2 and 30 add to 19? No. Will 3 and 20? No. 4 and 15? Ooh, I got there. Yayness. And so you won't have to go forever. Eventually you'll start to repeat the ones that are on this side, so there will be an end, I promise. But yeah, if you don't see them, just start with 1, go through it, you'll find it. Coming back to this, pulling out a GCF from the top, I'm going to pull out a 5n, I'll be left with n plus 3, pull out a 4, n plus 3. Heck yeah, it works, right? I used to not be a fan of the box because I thought it took too long to draw, and I still think that if you move up to pre-calc and stuff, you're going to want to wean yourself off of it. But in the beginning, it's quite nice. So we'll do maybe a couple more. So put the 2v squared here, put the 5 down there. I'm looking for things that multiply to make 10 that add to negative 11. So maybe a negative 10 and a negative 1. Negative 10 times negative 1 is positive 10. Negative 10 plus negative 1 is negative 11. I'm going to put those... Why did I have to add to a negative 11? I want to add to a positive 11. That's very positive. So let's make those both nice and positive. Everything's positive. I don't know why I went to introduce negatives there. So put a 10v there and a 1v there. Factor out a GCF from the top, so factor out a 2v. I'll be left with a v and a 5. Factor out a 1, v and a 5. It's working. I'll have 2v plus 1 times v plus 5. Let's see, anything more interesting on the back? This one gets a little big, this first one on the back, so let's try this. So 15n squared and a minus 6. Looking for things that multiply to make 90, negative 90. 15 times negative 6 is negative 90, and they have to add to negative 27. So let's see, what are we saying? So if we don't see it right away, we just start with 1 and 90. And they're basically going to subtract to 27. So you'll know it when you see it. We got 2 and 45, that's not going to make a 27. 3 and 30, oh yeah, that'll work, right? So if I do 30 and a 3 minus 30, right? 3 times minus 30 will be minus 90, 3 minus 30 will be minus 27. There it is. So I'll put the 3n and the minus 30n there, and I'll just factor out GCFs. So pull out a 3n, be left with 5n and a 1. Pull out a negative 6, and I'll be left with 5n and a 1. It's so working. So I have 3n minus 6 times 5n plus 1. And there you have it.